Hello and welcome to another video in our T-Level Digital Production Design and Development series. Today, we're looking at an important aspect of digital project management: risks, constraints, and dependencies. Digital projects are complex endeavors that require the convergence of data, systems, and people. This complexity introduces various risks that project managers and team members need to be aware of. Let's explore some of the key risks. One of the most significant risks in any digital project is failing to plan adequately. It's crucial that projects are carefully planned to minimize any disruption to the business's functionality during implementation. Without proper planning, you might find yourself facing unexpected challenges, missed deadlines, or budget overruns. For example, imagine you're implementing a new customer relationship management (CRM) system. If you fail to plan for data migration or staff training, you could end up with a system that no one knows how to use effectively. Or worse, one filled with inaccurate or incomplete data. Technology is constantly evolving, and this can pose a risk to digital projects. Changes to hardware and software availability due to new technology or upgrades can impact a project if these changes occur during implementation. This can prevent the new system from functioning as intended, or even make it outdated before it's completed. Consider a scenario where you're developing a mobile app. If a new version of the operating system is released midway through your project with significant changes, you might need to redesign parts of your app to ensure compatibility. Another risk factor is organizational change. For instance, if the organization merges with another company part way through the project, it can have a significant impact on the project requirements. The new merged entity might have different priorities, systems, or processes that need to be accommodated. Finally, a risk that's often overlooked is the potential loss of key project team members. If critical team members leave the organization part way through the project, it can lead to loss of knowledge, skills, and momentum. For example, if your lead developer leaves halfway through a complex software development project, it could significantly delay the project as you search for a replacement and bring them up to speed. Now that we've covered these key risks, I'd like you to think about this question. Can you think of a digital project you've been involved in or heard about, and identify any risks that were present or could have been present? How are these risks managed, or how could they have been managed? Take a moment to consider this. You might want to pause the video and jot down your thoughts. In our next section, we'll be discussing project constraints, so make sure you're ready for that. Thank you for considering that question. Let's explore a common digital project many of us might be familiar with: the development of a company website. This project can face several risks, and I'll outline 4 key ones along with how they could be managed. First, there's the risk of failing to plan adequately. The team might not fully account for all necessary features or content, leading to scope creep later in the project. To manage this, it's crucial to create a detailed project plan with clearly defined requirements and milestones right from the start. Second, we have the risk of changes in technology. New web standards or browser updates could affect the site's functionality mid-development. To mitigate this, the team should stay updated on upcoming changes in web technologies and build flexibility into the design to accommodate future updates. Third, there's the risk of losing key team members. Imagine the lead developer leaving halfway through the project. To manage this risk, it's important to ensure proper documentation of all work and cross-train team members to reduce reliance on any single individual. Lastly, we have the risk of organizational changes. The company might undergo rebranding during website development. To handle this, maintain open communication channels with company leadership and build flexibility into the design to accommodate potential changes. Remember, effective risk management is about anticipating potential issues and having plans in place to address them. This proactive approach can save time, money, and a lot of headaches down the line. Now that we've covered the risks involved in digital projects, let's move on to another crucial aspect: constraints. Constraints are the limiting factors that can impact the overall success and quality of a project. Understanding these constraints is essential for effective project management. There are three main types of constraints in digital projects, often referred to as the project management triangle or the triple constraint. Let's explore each of these. Time. Time is a critical constraint in any project. It's essential that the timescales for any project are estimated as accurately as possible. This requires a combination of research and expertise. For example, if you're developing a new e-commerce platform, you need to accurately estimate how long each phase will take, from initial design to final testing and launch. Underestimating the time needed can lead to rushed work and potential quality issues. Cost. All projects have a set budget, which must be adhered to. It's important that thorough research is carried out so that accurate costings can be established. Costs in digital projects typically relate to goods and services, hourly rates of employees working on the project, equipment. For instance, in a web development project, you need to consider the cost of web hosting, any third-party services or APIs you'll be using, the salaries of your development team, and potentially the cost of new hardware. Scope. The project scope is a guaranteed set of deliverables. This is what the project will achieve if successful, if the budget and timescales are appropriate and agreed upon. In a mobile app development project, the scope might include specific features and functionalities, supported devices and operating systems, and any back-end infrastructure required. A fourth constraint is quality. Quality is one of the major constraints of every project. The quality of the outcome of the project is dependent on the scope, time, and costs. It's crucial to understand that these four constraints are interrelated. Any changes to one or more of the other constraints can impact the quality of the project outcome. Similarly, any changes to the expectations of the quality can have an impact on time, scope, and cost. Let's look at an example to illustrate this relationship. Imagine you're working on a project to develop a new inventory management system. If the client suddenly requests additional features, increasing the scope, you have three options. Increase the budget to hire more developers, cost. Extend the deadline, time. Reduce the quality of the final product, quality. This relationship is often visualized as a triangle, where each side represents time, cost, and scope, with quality in the center. Changing one side of the triangle inevitably affects the others and the quality at the center. Now, let's test your understanding with a question. You're managing a digital project to create a new customer service chatbot. The project is halfway complete when the client requests a significant new feature: the ability for the chatbot to handle voice calls in addition to text chats. This wasn't in the original project scope. How might this change in scope affect the other constraints, time, cost, quality of the project? What options might you present to the client to manage this change request? Take a moment to think about this. You might want to pause the video and write down your thoughts. In our next section, we'll be discussing project dependencies. Let's consider the scenario where you're managing a digital project to create a new customer service chatbot, and halfway through, the client requests a significant new feature: voice call handling. This change in scope would likely affect all other constraints in the project management triangle. First, let's look at time. Adding voice call functionality would require additional development time, potentially delaying the project completion. The team would need to design, develop, and test this new feature, all of which take time. Next, consider the cost. New features mean more work hours, and possibly new technologies or infrastructure to support voice calls. This would inevitably increase the project cost. Regarding quality, rushing to implement the new feature within the original timeframe could compromise the overall quality of the chatbot. The team might not have enough time to thoroughly test and refine the voice functionality. So what options could you present to the client? Here are 4 possibilities. Extend the project timeline and increase the budget to accommodate the new feature without compromising quality. This maintains the desired scope but adjusts time and cost. Implement the text-based chatbot as originally planned, then create a separate phase for voice functionality. This maintains the original project constraints, but delays the delivery of the new feature. Reduce the scope of other features to make room for voice functionality within the original timeline and budget. However, this might affect overall quality or functionality. Maintain the original project as is, and propose the voice functionality as a future upgrade project. This preserves the original project constraints, but delays the new feature indefinitely. Each option has its pros and cons, and the best choice would depend on the client's priorities and the project's specific circumstances. The key is to clearly communicate how changes in one constraint inevitably affect the others. We've covered risks and constraints, and now we're moving on to our final topic: dependencies in digital projects. Understanding and managing dependencies is crucial for ensuring smooth project progression and successful delivery. What are dependencies? In project management, dependencies refer to the relationships between tasks where the completion or initiation of one task relies on the completion or initiation of another. It's important to the success of any project that these dependencies are clearly set out and managed effectively. The project manager plays a crucial role in managing dependencies. Their responsibilities include setting the sequence of tasks within the project plan, calculating the time each task will take, often referred to as the task's critical path, identifying the resources required to complete each task and potential scheduling problems, monitoring and managing the tasks, identifying and actioning any opportunities to accelerate the project schedule. There are 4 main types of project dependencies, each describing a different relationship between tasks. Let's explore these. Finish to start, FTS. This is the most common type of dependency, often referred to as a finish to start dependency. In this scenario, the first task, predecessor, must be completed before the next task can start, successor. For example, imagine a project to install new robotic machinery in a manufacturing company and train staff to use it. The training of staff, successor task, cannot start until the installation of the robotic equipment, predecessor task, is completed. Start to start, STS. In some projects, tasks need to be carried out in parallel. These projects often use the start-to-start methodology. For instance, in a project to implement a new digital system, you might have 2 parallel tasks: monitoring the new system's performance and carrying out stress testing. The stress testing can be carried out alongside the monitoring, but the monitoring must start before the testing can begin. Finish to finish, FTF. In this methodology, tasks can run in parallel, but a successor task cannot complete until its predecessor task has completed. Consider a project where a new network system is being installed along with new network cabling. While the devices can be prepared and tested individually, they cannot be tested as part of the network until the installation of the new network cabling has been completed and tested. Start to finish, STF. This is the least common type of dependency. Here, the predecessor task can only finish once the successor task has begun. An example would be the installation of a new software program to replace an out-of-date system. While the new software is being installed, configured, and tested, the old system still has to function to enable the business to continue with its day-to-day activities. The old system cannot be deactivated or removed until the new system is up, working, and ready to function. Let's test your understanding with a question. You're managing a digital project to develop and launch a new e-commerce platform. The project includes tasks such as back-end development, front-end design, payment integration, security testing, and user acceptance testing. Can you identify at least one example of each type of dependency that might exist between these tasks? Explain your reasoning for each. Take a moment to think about this. You might want to pause the video and write down your thoughts. Let's walk through an example of each type of dependency in our e-commerce platform development project. First, we have finish to start, the most common type. In our project, back-end development must be completed before payment integration can begin. This is because the payment system needs to interact with the back-end, so the core back-end functionality needs to be in place first. You can't integrate payments if there's no system to integrate them into. Next, let's look at start to start. In our project, front-end design can start once back-end development has begun. They don't need to be fully in sync, but the front-end team needs some understanding of the back-end structure to start their work. They might begin with wireframes or basic layouts, while the back-end team is setting up the database structure. For finish to finish, consider security testing and back-end development. Security testing cannot be completed until back-end development is finished. While security testing can start earlier, the final security approval can't be given until all back-end development is done. You need to ensure that every part of the completed back-end is secure. Lastly, we have start to finish, the least common type. In our project, user acceptance testing can only be considered complete once the launch of the platform has begun. This ensures that the final deployed version of the site is what's been tested and approved by users. The start of the launch triggers the finish of the testing phase. Understanding these dependencies is crucial for project planning. It helps you sequence tasks effectively, allocate resources efficiently, and identify potential bottlenecks before they become problems. Remember, in complex projects like this e-commerce platform, many tasks will have multiple dependencies, creating a web of interconnected activities that need careful management. We've covered a lot of ground today in our exploration of risks, constraints, and dependencies in digital projects. Let's quickly recap what we've learned. We started by examining the various risks that can impact digital projects, from inadequate planning to changes in technology and personnel. Remember, being aware of these risks is the first step in managing them effectively. Next, we delved into the constraints that shape our projects: time, cost, scope, and quality. We saw how these elements are interconnected and how changes in one area can affect the others. Finally, we explored the concept of dependencies in project management, looking at the 4 types: finish to start, start to start, finish to finish, and start to finish. Understanding these dependencies is crucial for effective project planning and execution. In our next video, we'll be moving on to topic 5.1.5. How digital is used to meet user needs and ensure quality of products and services. This is an exciting area where we'll explore how the digital tools and concepts we've been discussing are applied to create value for users and maintain high standards of quality. Thank you for your attention today. Remember to review these concepts and try applying them to your own projects or case studies. If you have any questions, don't hesitate to ask in the comments section below.